Kiwi Bird. You can call me Kay. That's a picture of me right there. Today, I'll be talking about how your local grocery store clerk is plotting to become your new governor one day. Just kidding, I'm actually going to talk about science. Today, I want to talk to you about the process of protein synthesis. This is a cell, and here is the nucleus, the kingdom of the cell. Within the cell lies its ruler, DNA. If we were to be without him, we wouldn't be able to make sandwiches. Wait a minute, should I call DNA her? I don't really know DNA that well. Should I? You know what? Whatever. DNA is also known as deoxyribonucleic acid. Oh, I do a very terrible job lip syncing. Oh, and has two backbones, unlike you. These two backbones spiral into each other into something called a double helix. Wait, helix? No, change that to helix. The helix is made of nucleotides, each of them made up of bases. Without these bases, we wouldn't be able to enjoy oranges. To repeat what I said earlier, since it takes a while for these letters to be written, there are 4 of these so-called bases, and these bases are called adenine, thymine, guanine, and cytosine. They are all married to each other, adenine to thymine, guanine to cytosine. They are bound together with hydrogen bonds. Correction, they can become unbound. But how? This is where the little brother of DNA comes in, called RNA. RNA is ribonucleic acid. RNA has 4 bases in it, even though there's no thymine. Uracil takes the place of thymine. RNA can connect to itself, since it's made of only one backbone. RNA is also able to pair with DNA. Surprisingly, this process is called transcription. There is an area on DNA that starts at the promoter and ends at the terminator. Between these two areas, a material called RNA polymerase forms. Now, the RNA polymerase proceeds to connect to the DNA by collecting nearby bases. The forming RNA shall be the opposite of DNA. So, if DNA went as adenine, guanine, cytosine, and thymine, RNA would be uracil, cytosine, guanine, and adenine. Only select areas of DNA are connected to the RNA. These areas are called exons. The leftover areas that are not used are called introns. We now have a delivery boy for the protein production service, messenger RNA. Every 3 bases on mRNA is called a codon. They connect to their opposites, anticodons, which are located on transfer RNA. The purpose of transfer RNA is to carry one of 20 amino acids, the monomer for a protein. It's time to go to work at the ribosome, where the process of translation occurs, the creation of a protein. The ribosome is split into 2 units called subunits. In the smaller subunit, mRNA proceeds to enter. The tRNA will connect to the larger subunit, where it shall connect to 3 different spots. These areas are called binding sites. There is the A site, the P site, and the E site. tRNA always begins at the A site, where it connects to the proper mRNA codon. Moving on to the P site, the tRNA now drops off the amino acid at the beginning of a peptide chain. We end at the E site, where the tRNA finally disconnects from the ribosome. This process continues as the amino acids bind onto each other with peptide bonds continuously on and on and on until the tRNA connects to one of the 3 stop codons. These codons have no amino acids. This brings the process of translation to a stop. Oh no, the ribosome's falling apart. Don't worry, it's just making room for an enzyme called the release factor. The release factor sets the newly formed protein free from the ribosome. Just pray that a mutation doesn't happen to you. A mutation is a mistake in your DNA. More specifically, the basis of your DNA. What you're looking at is my mutation, a frameshift mutation. This is where a nucleotide base gets added or deleted where it shouldn't have been. In my instance, a necessary cytosine base has been removed from my DNA, resulting in the RNA codon ACU instead of ACG. Because of this mutation, I am now a sentient kiwi bird. I have human intelligence. I don't want to be sentient. Anyways, now you know about protein synthesis, how proteins are made. Proteins are made in your body forever and ever and ever until the inevitable comes. The inevitable will always come. Anyways, have a wonderful day.